Hello everyone, today we'll be looking at usaco-training combination lock. In this problem, we're given basically like a combination lock, which basically has three numbers. And then we're given n, which is like the number of numbers in each of the three numbers, which means that, for example, if n equals 50, then each of the numbers can be from 1 to 50. Okay. And then we're given Farmer John's combination and the Master's combination. And then we're supposed to find the number of combinations that can fit either of those two combinations. And a combination can fit if let's see, so it has to be close to at least one of these specific combinations. So it has to be adjacent. Wait. Okay, so it has to be within at most two positions. So for example, for 4, 5, 6, 1, 3, and 5 would work since each is in like in within two positions. And they also work backwards since the next one of 50 is 1, and then the next number of 1 is 2, and blah, and on. So it's basically like a circular one. So 50 would also work for 1 as well. So for this case, we're given n equals 50. And Farmer John's combination is 1, 2, 3. And the Master's combination is 5, 6, and 7. So we're supposed to count the number of combinations that work on either of these. So for example, 1, 1, 1 works because it's within Farmer John's combination, since 1 is equal to 1 and the distance between 1 and 2 is 1, and distance between 1 and 3 is 2, which is less than or equal to 2. And for 5, 6, 7, you can have these combinations. Okay. So let's just put out the problem. So we're given 1, 2, 3 for Farmer John's combination. And we know the Master's combination is 5, 4, and 6. Okay. So and in this case, n is equal to 50, which means that each of these can be from the range from 1 to 50. Okay. Now you can see that, okay, so we're supposed to count the number of combinations that work. And then since the maximum of n is equal to 100, okay, so let's just say for any combination. Okay, so here the first number, let's call this x, y, and z. This can be from 1 to 100. This can also be from 1 to 100. And this can also be from 1 to 100. You can see that if we generate all the possible combinations, we only will have 100 to 3. Our time would only be 100 to 3 of O, which can't fit. So now all we need to do is just to check for a given x. This is actually supposed to be z. So 1 second. Here we go. So x, y, and z. So now all we need to do is check if for a given x, y, and z works, if it fits in Farmer John's combination or if it's in the Master combination, since we know how to generate all the possible combinations. Okay, so now let's just say here's our x, and then our Farmer John's is 1. Okay, so we can basically kind of check the distance between the two nodes. So by doing that, you can do it like this. Okay, so you can check. You can basically find the minimum distance on two sides, or you can just find the distances on two sides. For example, if you have 1 and 50, you can the distance would be 0, it will be 1 because you could, because it's basically adjacent. Okay, so let's just make a formula. So let's just say if it's 1 and 2, then the distance would just be the greatest minus the least, which is 2 minus 1, which is equal to 1. So let's just say you have 1 and 50. Then the distance would be, you have your greatest, okay, and then it would actually be n minus 50 plus 1, which would be, in this case, 50 minus 50 plus 1, which is equal to 1. This works. We can also take, let's just say 1 and 49. This would be 50 minus 49 plus 1, which is equal to 2, which is what we have. So now we have our two distances. So for example, for 1 and 50, you actually have two distances, which is 1, and it is 1. And there's the other way, which is 50 minus 1, which is 49. So to check if it works, you just check if the minimum of the two distances is less than or equal to 2. So now for each of our digits, we can first test if it's Farmer John's combination, and then we can test if it's the master combination. And if either one of those works, then we can just add 1 to our counter. Okay, so this is called, wait a minute, this is called combination lock. Okay, so let's just include, actually, let's just use vector. Okay, and we should also use, actually, let's just use f stream as well to use for our input. So now we can just use using namespace std. Okay, so we're given n, and then we're given two arrays, so we can represent them in a vector. So let's call this A and B. Actually, let's just call this Farmer John and Masters as a mess. So we need our main function. Whoops. So we need to read from in this case it is called combo.in. You can do fstream fn combo.in. You write to combo.out. So you read n, and then each of those would be link 3. So you can actually just define it there. Okay. Okay, so you also read the master one, so B as well here. Okay, so now we need to generate all the possible combinations. So here we would have for int I equals, okay, so it can be from 1, and then, okay, let's call this, remember we have x, y, and z, so this should be x. This should be less than or equal to 10, n. Okay, so you would actually do the same for, let's actually make a empty line here, y and then z, here be also z, here be y, and z. Okay, so now we need to check if this works. Okay. So for here, we need to, let's just check for fj, or Farmer John. So let's define a distance function. So it's basically, so we should have a distance between a and b. So this should return the minimum distance. So we want a to be the greater of those two. So if a is less than b, you just swap a, b. Now just take the minimum of a minus b, and as we said before, it would be n minus a plus b. Okay, so this would be our distance. Let's call this d to be short. Okay. So now let's check for fj. So we need to compare x and fj of 0. So we can, if the distance of x and fj, or we can actually make this, let's just call this check. So let's call this check. So this should actually be Boolean. So we have to return this if this is less than or equal to 2, which means that if this satisfies the conditions. So if if check of x and fj of 0 and check of, now we're comparing y and fj of 1 and c of z and fj of 2. So if this works, then you can have your answer increment. So now we need to declare answer. Since we haven't declared it, answer is 0. Okay, so now if this doesn't work, so now we need to check if XYZ works with the master combination. So we need to check if, first one, if X and the master of 0 and check of Y and master of 1 and check of Z and master of 2. So if these work, then you also can increment your answer. Okay, so now all you do is just print your answer. Whoops. Okay, so let's just create a file. So combo.in. Just going to copy it. Okay, here we go. Okay, it's running. Okay, I'm just going to write the, okay, let's see, 249, which is correct. Okay, I'm just going to submit this to make sure. So my ID is $3. This problem is called combo, and my language is C++11. Okay. Okay. Whoops, not that. This. Okay. Okay, this is called combination locks. Here we go. Okay, so it looks like that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.